at Davos at the World Economic Forum, and I have the privilege to interview an amazing scientist, Dr. Krauss. He is a cosmologist and has been working on the beginning of the universe. Dr. Krauss, can you tell us a little bit about your work?
Well, yes, of course. I actually work on the beginning and end of the universe. The end is miserable, by the way, so maybe we should concentrate on the beginning. The amazing thing is that there's been a revolution in our understanding of the universe in the last decade. We've learned how insignificant we are, that we're much more insignificant than we thought we were, even before. Our sun is just one of 100 billion suns in our galaxy, and there are over 100 billion galaxies in the universe. But in fact, we've learned that if you take all the stars and all the galaxies and everything we can see in the universe, it accounts for almost nothing. It accounts for less than 1% of the total mass of the universe. Most of the universe is the stuff you can't see, the stuff between the stars. We've learned that the universe is dominated by something called dark matter, which is we think some new type of elementary particle that's going right through you now as we do this interview. But even more interesting, empty space, it turns out, has energy. And the empty space in the universe is the dominant energy in the universe. And what makes that exciting is we don't have the slightest idea why it's there. It's the biggest mystery in science. And those are some of the issues that I work on. I'm trying to understand the nature of dark matter, actually propose the existence of dark energy, and trying to think of ways to try and learn what it is. Because the wonderful thing about the universe is, because it's expanding, it means it was once much smaller. And to understand the universe at the very largest scales, if we think back, the conditions of that universe were created at the very smallest scales. So to understand the very largest things in the universe, we have to understand the very smallest things in the universe. It's a wonderful, wonderful connection.
Let me ask you this, because I remember in your talk that you say, we come from stars. Each of us comes from a different star. And I was shocked by that. So can you explain it?
Sure. It's one of the most poetic things I know about the universe is that every atom in your body was once inside a star. And in fact, the atoms in your left hand could have been in a different star than your right hand, because all of the elements that really make you up, the important elements, the carbon, nitrogen, oxygen, iron, all of those things were not created at the beginning of time. In the Big Bang, the only elements that were created were hydrogen, helium, and a little bit of lithium, but all the important stuff is made in the fiery furnaces and the cores of stars, and the only way they could get into your body is if the stars were kind enough to explode for us. And then, so every atom in your body has experienced perhaps the most cataclysmic, violent explosion in the universe, called a supernova, and every atom has experienced that, and so you really are stardust. We are all star children.
So we are all really stars here.
We're connected. We're directly connected to the cosmos, and for me, that's one of the most poetic things in the universe. I've actually wrote a whole book about it because it's so poetic, and
it's beautiful.
It's a nice connection. And when people ask why should I care about cosmology, as someone asked the other day, there are many reasons, but one of them is because you're part of the cosmos, and
yes,
and you have an intimate relationship.
Yes, absolutely. So tell us a little bit about life in other planets.
Okay, well, that was another thing I talked about here, in the sense that we're having a revolution in not only our understanding of life, but the fact that our ability to probe it. And we've learned, I expect in the next decade, we will discover life probably elsewhere in our solar system. Maybe fossilized life, but we've learned that there are various locations in the solar system, like Mars and maybe some of the moons of Jupiter, where there are liquid oceans underneath massive ice crusts, where there might be conditions that are conducive to life. And in fact, we've also learned the material gets exchanged from no planet is an island, that when a meteor hits Mars, some of the material comes to Earth and vice versa. So we could be polluting each other with our life. And if we discovered, for example, life on Mars, the big surprise would be if it weren't our cousins. But more interesting, with our new telescopes, we're able to discover planets around other stars. We now discovered over 400 planets. In fact, there's going to be an announcement in a week or two about maybe another 700 planets. And as we look at those planets cross the stars, we can see the light from the star dim a little bit, and that's how we can discover the planet. But if we are very careful and look at the spectrum of light that comes from those planets as the light from the star goes through them, we can look for things like oxygen in the atmosphere. And that's very important, because all of the oxygen that you and I are breathing right now was created by life. When the Earth began, there was no free oxygen. Life created the oxygen, and so if we saw free oxygen in another planet's atmosphere, it would be very good. It would be very good evidence that there's life elsewhere. So it's a very exciting time.
So another question that I had for you, that I heard from your talk, is: so how long are we going to have the sun?
Well, the sun happily will be burning bright as it is here in Davos for a while. You don't have to worry too much, but it'll be about 5 billion years. The sun will use up its all of its hydrogen fuel, and then as it actually dies out, before it does, it'll be rather bad for the Earth because the outside will expand and the Earth will end up inside the sun, so it won't be a very pleasant place to be.
But then we will have found another planet to live, right?
If we're smart enough, we hope we will. So on my good days, I think that a civilization that could make Rodin sculptures and write Shakespeare's plays could in some sense have the wisdom and creativity to think about the future. But then some days I look at what we're doing about global warming and climate change, and I think maybe we won't be able to save ourselves. The interesting thing, by the way, is it doesn't matter for your atoms, because if we destroy ourselves here on Earth, when the sun eventually encompasses the Earth, it'll blow off the Earth's atmosphere, and our atoms will end up in the cosmos anyway.
So
or they could come with us.
Infinite.
Well, exactly. Well, our atoms certainly don't care what happens to us, because if we go away in spaceships, we'll carry our atoms with us. If we destroy ourselves, our atoms will still end up in outer space. So for them, the future is the same. We're just here for a cosmic instant, and I like to say we should make the most of our brief moment in the sun.
So we are a cosmic miracle, and I think that this is one of the most exciting talks that I've heard here at Davos. Thank you very much.
Thank you. It was a lot of fun. Thanks.